Okay, let's review our inequalities unit. There's a lot of things in this unit to remember, and it's been a while since we've done them. If you tried these traditional inequalities, there's really not a whole lot to remember. Okay, you're solving them exactly like you do an equation, but when you're working with inequalities and you divide by a negative, you have to reverse the direction of the sign. So this would become less than or equal. Okay, second one, this one's a little tough with the fractions. Remember, we want to get rid of the parentheses, so we could multiply each of those by negative 5/4. That's going to give us negative 15 halves x plus negative 5 halves, less than negative 40. And it's up to you here. If you remember, we learned a trick. If you want to get rid of all these fractions, we could multiply both sides of this equation by 2. What that does is that'll cancel with the 2's here. So I end up with negative 15x minus 5 is less than negative 80. And then from there, you can just use your steps to solve. Okay, again, remembering anytime you divide by a negative, you have to reverse the sign. All right, compound inequalities. Remember, compound is when you have two inequalities put together. So really, these are just graphing. An OR problem typically looks like this. Okay, so let's see, x is less than 2, open circle at 2. Or x is greater than or equal to 4. Remember, that would be a closed circle going this direction. So that's a pretty typical one. The second one with an and, we usually have the intersection. So let's see what happens. X is greater than or equal to negative 3. Closed circle going this way. And x is less than 4, so open circle here going less than, so we would get that intersection between those two. Okay, and remember, an and problem can also be written this way. So that's just another thing to look for when you see an inequality written that way. That's a compound inequality, that is an and. All right, let's see. The next one, these are, of course, two exceptions. X is greater than 2. So that would look like this, or x is greater than or equal to negative 1. So remember, when we have an or, we're looking for anything that is covered in that area. So technically, we really only need this. The last one, x is greater than 2, and x is greater than or equal to negative 1. Okay, remember, with an and, we're looking for where they intersect. So they would intersect from here up. All right, let's look at the tougher ones from this unit, the absolute value inequalities. First thing you want to remember is anytime you have a less than or equal, that signifies an and compound inequality. Oops, there it is. If you have a greater than or equal, that's going to be an or compound inequality. All right, when you have absolute value, remember, we want to get the absolute value by itself, and then we're going to split it into two inequalities. The first one is written exactly the same, okay, without the absolute value signs. The second one, you're going to reverse the sign and take the opposite of 7. And since this is a less than, that's going to be an and. All right, I'm going to solve these kind of quickly. All right, and then if we graph those, x is greater than negative 2, x is less than 5. So that would be what an and should look like. Okay, the second two inequalities, the problem is you need to get the absolute value by itself before you split it into 2. Okay, so let's do that first. We're going to add 12 to both sides. I get 21 on this side, and I have 7 times the absolute value, x plus 5. I would need to divide both sides by 7. That's going to give me x plus 5 absolute value greater than 3. Now I have the absolute value isolated, so now I can split it. So the first one is always written exactly the same without the absolute value. This is a greater than, so it's going to be an or. And then the second one, I flip the sign and I make the 3 a negative 3. Okay, so we get x is greater than negative 2, or x is less than negative 8. So that's a typical or. All right, the last one, let's get the absolute value by itself. Divide both sides by negative 6. All right, and at this point you would split it, okay, but hopefully you see here we have an absolute value which will always be a positive number, and they're saying that that has to be greater than or equal to a negative number. So this would always be true. The absolute value, a positive number, will always be greater than a negative. So this is one of those special cases where we say all reals. And if you're asked to graph that on a number line, you would just shade the whole number line. All right. Had you split that, you would have made an or, and we would have had a graph that went in both directions, which would cover the whole number line. So that's another way at the end that you hopefully would recognize that the answer to that is all real numbers.